Sorry students, the video is stopped unexpectedly. So again let me explain. Concave mirrors, so center of curvature means center of center of hollow sphere where the mirror is a part. Okay, so this is indicated by C. Pole means the center of a concave mirror is called a pole. So radius of curvature, it is the radius of the sphere where the mirror is a part is called radius. Means it is the radius of the sphere where this mirror is be extracted. Okay, principal axis, the straight line passing through the center of curvature and pole. Okay, so next, focus point. Parallel beam of light falls on a surface of a concave mirror, they converge at a focus point. Okay, so that is called as a, so this focus point is, so let me say focus point F, right? F, this F is exactly between these center of curvature and pole. Okay, so exactly between the center of curvature and pole. So let us say here is a focus point. Okay, so the length, the distance between pole and focus point, this focus point, right? F, this length is called focal length, indicated by small f. Okay, so this is a f, right? So focal length, what is focal length? The distance between pole and focus point f. Okay, so small f is equal to, means focal length is equal to r by 2, right? Means radius by 2, because we said this focus point is exactly between center of curvature and f, right? So their focal length small f is equal to r by 2. Okay, so this is about concave mirror. Okay, so let us consider convex mirror. Okay, okay, so in convex mirror also same focus. So here this is a reflecting part. Okay, this is C, center of curvature, same. Okay, so this is a center of the hollow sphere where uh, convex mirror is a part. Okay, so next, again pole, same pole. Pole is a middle part, middle means center of this convex mirror. Okay, so next, focus point we already discussed. When a parallel beam of light falls on this convex mirror, they appear to diverge from a point. Okay, so they appear to diverge from this point. Okay, so from this point they appear to diverge. Okay, so this called focus point, same. Okay, so what focus point, let us a little bit different this focus point definition. Okay, f, so the point where the parallel beam of light appear to diverge is called focus point. Okay, F. So this is a focus point. So again the same line joining, the straight line joining this pole and center of curvature is called principal axis. Principal, the straight line joining, same definition. Radius of curvature also same. This total is a radius of curvature. That is the radius of the sphere where the mirror is a part. Okay, next focal length. And here is also, in this case also, this focus point is lies exactly between C and P, pole and center of curvature. So focal length is equal to the distance the distance between, okay, the distance between pole and focus point. Focus point. So small f is equal to r by 2 in this case also. Okay, so this is about concave and convex mirrors of different terms. Okay, so let us discuss now laws of reflection. We already discussed in yesterday's class, right? So if you draw, see these two laws of reflection also applicable for these concave and convex mirrors, we already said, right? So try to draw a, let us consider this is a concave mirror, right? Concave mirror. So a parallel beam of light falling on this. Okay, so what happens, they converge, right? They converge. These are the reflected rays. Okay, they converge here. Try to draw normal. Okay, so again you will get I and R equal. Okay, here also draw I and R. I and R will always equal. So in convex mirrors also, this is the back side. Parallel beam of light falls and diverge, right? Try to draw normal. Okay, you will get a angle of incidence is equal to angle of a reflection. Here also angle of incidence is equal to angle of reflection. Okay, this is normal. Angle of incidence, angle of reflection. Normal, angle of incidence, angle of reflection. In all the cases, all the mirrors, always angle of incidence is equal to angle of reflection. So plane mirrors are made up of, how they made, for a glass, they will paint with a silver or aluminum. Okay, in olden days they used to coat with a silver, and they used to protect the silver cover by paint. Okay, so suppose this is, consider this is a plane mirror. So they used to paint a backside, and they used to protect this backside by using paint. So what is this here? Silver coated. Okay, silver coated, or even aluminum also. So silver is very costly. That's why in coming up days or nowadays they are painting with the aluminum. Even aluminum also a good reflector of light. Okay, so this aluminum coat is protected by this paint. Okay, so while drawing a ray diagrams, we use the mirror symbol as this. Always the back side of the mirror is indicated with these lines. It means this back side of a mirror. Okay, this is reflecting part. Okay, So this is reflecting part. So in yesterday's class we already discussed angle of reflection is equal to angle of incident by using a activity, right? Let us one more time discuss, and we have to let us one more time discuss and define each of term, what is incident and what is reflected ray and all, and plane of reflection also. This is plane mirror. Okay, so I'm drawing normal at one point. I'm taking at one point, this is normal. So normal is a ray, normal ray is a ray which always perpendicular to this plane mirror surface. Okay, surface of the plane mirror. So I'm taking 2 points and join these 2 points by using a line. This acts as a incident ray. Okay, incident ray. Suppose P and Q, these 2 points, you can see these 2 points in a mirror, right? P and Q. Okay, let us take P and Q. Observe from this side, this should be in a straight line. Try to see the straight line and try to correctly see and place one more two more pins, R and S. Okay, they should be like this and also like this little bit front. Okay, yes. So try to measure this angle little bit. My diagram is not good. You should if possible, try to do this experiment practically. Okay, angle of incidence is equal to angle of reflection, and all three are lying in the same plane. So second law also obeys here. Okay, so this is about the plane and curved or spherical mirrors. Okay, so in the next class we'll try to draw ray diagrams uh, by using how to detect a object in a plane mirror. Okay, discuss a small concept to tomorrow. So this is the end of your light lesson for 7th and 6th classes. For 8th class we'll see the ray diagrams, how to identify a object in a plane mirror. Okay, thank you. So one more announcement, children listen. So before about mirrors, that video stopped in the middle, right? Try to go to this YouTube channel. Try to visit these both videos. I'm uploading only first video. You go to this type, go to YouTube and type this ID. You will get a plane mirrors part 2. That also try to visit. Okay, so try to visit and try to do the homework, today's homework. So thank you.